The potential difference between the two terminals of a cell is 3 volts. Find the work done in moving 5 coulombs of charge across the cell. So we need to calculate how much work is being done in moving 5 coulombs of charge. So let's see what's given to us. We have a cell. Let's say this is our cell. And it's given that across the ends of the cell, across the terminals of the cell, the potential difference is 3 volts. And to calculate work done from this number, we need to first understand what this number really means. So we have seen in a previous video that volt really means joules per coulomb. And this is telling us that 3 joules of work is needed to move every coulomb of charge from one point to another. 3 joules per coulomb. That's what we mean by 3 volts. It's an indicator of how much work needs to be done to move a coulomb from one point to another. So now that we know what it means, what is the meaning of potential difference, let's see if we can answer the question. We need to calculate work done in moving 5 coulombs of charge. What we already know is to move 1 coulomb, we need to do 3 joules of work. To move 5 coulombs, how much work do we need is the question. So with this data, pause the video and see if you can try and answer this question yourself. All right, now let's do it. So 1 coulomb to move from one point to another, 3 joules of work. If you had 2 coulombs, it would be twice the amount. If you had 3 coulombs, it would be thrice the amount. So to move 5 coulombs, it would be 5 times the amount. So work done would be 3 joules per coulomb. This is 3 joules for every coulomb. But since we are moving 5 coulombs, we multiply it by 5. And that would be, the coulomb cancels, that would be 15 joules. So we need to do 15 joules of work to move 5 coulombs across. So notice that if we understand what voltage is or potential difference is, if we understand the meaning of volts, we don't have to remember any formula. We can just logically solve problems like this. Let's try another one. It takes 20 joules of work to push 4 coulombs of charge across the filament of a bulb. Find the potential difference across the filament. So great idea to pause the video and see if you can try this problem yourself first. All right. In this question, we are asked to find what the potential difference is. And what we are given is the work done to push 4 coulombs of charge across the filament of a bulb. So let's say here is the filament of a bulb. We know to push 4 coulombs of charge, across the filament, it takes 20 joules of work. 20 joules of work. So given this, we are asked what is the potential difference across the filament. Well, again, if we go back to our definition of what potential difference is, it's a measure of how much work needs to be done per coulomb. Now, we know to push 4 coulombs of charge, we have to do 20 joules of work. So to move 1 coulomb, how much work should we do? Well, the amount of work that we need to do would be 20 joules per 4 coulomb, because that's what voltage is. Voltage is a measure of how many joules per coulomb. And that would be 5 joules per coulomb. Let's use the same color. So 4 goes 5 times, so that'll be 5 joules per coulomb. And joules per coulomb is what we call as volt. And so the potential difference across the filament of the bulb is 5 volts. Again, notice we didn't have to use any formula. All we did is use the definition of voltage or potential difference.